The purpose of the Air Data Inertial Reference System ADIRS is to provide air data and inertial information to the EFIS system, the FMGC, and other users. The A320 is equipped with 3 separate but identical Air Data Inertial Reference Units. Each ADIRU combines an Air Data Reference Computer, or ADR, and a Laser Gyro Inertial Reference System, or IR. The ADR and IR systems of each ADIRU operate independently, and failure of one system will not cause failure of the other. The ADR part receives information from aircraft probes and sensors. The ADR part provides various items of air data to the Flight Management and Guidance Computers, FMGC, and other users. The air data provided includes Mach, airspeed, temperature, overspeed warnings, barometric altitude, and angle of attack. The IR part provides inertial data to the FMGC, EFIS, and other users. The inertial data provided includes track, heading, acceleration, flight path vector, aircraft position, ground speed, and attitude. The 3 ADIRs are controlled through the ADIRS panel, located on the overhead panel. They are initialized through the 2 MCDUs located on the pedestal and by 2 of the switches on the switching panel located at the front of the pedestal. Independent data is supplied by each ADIRU. Let's see an example of this. In the EFIS system, ADIRU 1 supplies the captain's EFIS and ADIRU 2 supplies the first officer's EFIS. ADIRU 3 is available as a backup to either EFIS system via the switching panel. Use of the switching panel will be covered in the abnormal section. Now let's look at the ADIRS Control Display Unit. The panel is divided into 2 parts, the upper section for the IR and the lower section for the ADR. The 3 rotary mode selectors have control over both the IR and the ADR. The controls and indicators for the individual ADIRUs are grouped and arranged in the following order: 1, 3, and 2. Each ADIRU has an associated IRS rotary mode selector. In the off position, the ADIRU is not energized, so ADR and IR data is not available. In the navigation position, the ADIRs are energized. The navigation position is the normal mode of operation, and full inertial data is provided to the aircraft systems. The on-bat light illuminates to inform the crew that the ADIRU system is being powered by aircraft batteries only. The light also illuminates for a few seconds at the beginning of a full alignment as a test of the battery circuit. We will discuss this further in the normal and abnormal operation modules. Each inertial reference unit has an associated indicator. The align light illuminates steady white when the respective IRU is operating normally in align sequence mode. The align light flashes white if there is an IRU alignment fault, no present position entry has been made after 10 minutes, the difference between the position at shutdown and the entered position exceeds 1 degree of latitude or longitude. Present position information for ADIRS alignment is normally entered via the init page of the MCDU. This method will be explained in the normal operation module. The type of information displayed is selected with the data selector. The system selector enables the crew to switch the display off or select one of the three ADIRUs for display. We select System 3 for you. Notice that the display now contains the present position or PPOS information for ADIRU 3. The wind position indicates the true wind direction and wind speed. The heading position indicates the true heading. With heading selected during IRS alignment, the time remaining until alignment is complete is displayed. This is shown by a TTN, time to navigation indication. The duration is approximately 10 minutes, but it can increase with the aircraft latitude. The status position displays IRU status and guidance to the pilot in abnormal situations. For example, the current display is showing Enter PPOS, asking you to enter the present position of the aircraft. The track and ground speed position indicates the true track and ground speed of the aircraft. The spring-loaded test position tests the lights on the keyboard and produces a test pattern in the main display, as shown. The keyboard is a standby facility, allowing, for example, entry of present position for alignment of the IRS. You will see an example of the keyboard use in the abnormal operation. The following items can also be used in case of given failures. The AT position of the ADIRS selectors allows the selection of this IR mode, providing only heading and attitude information in case of loss of navigation capability. The three ADR switches normally remain on, but they can be selected off in response to ECAM procedures. When done, it only stops the ADRs, not the IRs. We will discuss these in the abnormal operation modules.